video 3, so make sure you're watching the right video. This is video 3 of the Chapter 9 test redo. First problem you were supposed to do, if you're watching video 3, is number 17, and it looks something like this. As soon as I see that picture, I think of the leg and the altitude theorems. That's x there, this is 3 here, that's 8. So what I'm going to do on this one is set up one of those two theorems. In this case, since I'm looking for this side right here, that's a leg, so I'm probably going to use the leg theorem. Leg theorem looks something like this. Remember, the leg is the geometric mean, so it goes in both those spots. That one leg of the big triangle, forget the altitudes even there for a minute, it's just the leg of the big right triangle. Leg goes there, the same leg. This is the whole hypotenuse on top, and on bottom over here is the part of the hypotenuse that's adjacent or hooked to that certain leg. So when I go to set that up, first thing, they didn't tell us the whole hypotenuse, but we can add 3 plus 8 and we get 11. That goes right there. Then we got the leg goes on bottom here, leg goes on top there. So it's x and x. Then we want the part of the hypotenuse. When this altitude's drawn in here, it splits the hypotenuse into two parts. We want the part that's hooked to the leg. Well, that part this time happens to be 3. So that's our setup. We cross multiply, you end up with x squared equals 33. Solve that, take square root of both sides, you end up with x equals, I would accept, since 33 is not a perfect square number, I would accept that answer. Or if you change it to a decimal, you grab your calculator and you hit square root of 33 and you get about 5.7. I would accept either one of those two answers. The next one you had to do if you're watching the third video is number 9. Number 9. Number 9 looks something like this. Got a 45-degree angle here. This side is 9. This is C. The redo says solve for x. In this case, you're actually solving for C. I forgot that there was some other different variables on here other than x. So you're solving for C this time. Since we know this is 45, that's 90. This has to be a 45-degree angle and in a 45, 45, 90 triangle. Sides across from the 45-degree angle should be labeled L and L. Side across from the right angle, L times the square root of 2. We look right here, that's the side they told us, and you set up that equation. L equals 9, nothing to solve there. All you got to do is everywhere you see L, you stick in 9. So I'm going to come right up here and place that L. I'm going to stick 9 in its place. Well, if I stick 9 in its place, now that side is 9 radical 2. So that's our answer. C equals 9 radical 2. You could have also used like sine, cosine, tangent, the trig ratios on this problem. And if you did, you'd get a decimal form of this. So if you wanted to check, see if your decimal form is correct, just take 9 times the square root of 2, see what that gives you, and it should give you the same answer as when you did sine, cosine, or tangent. Next one after problem 9 is problem 1. Problem 1. Problem 1 looks something like this. As soon as I see this picture again, I'm thinking leg or altitude theorem. This is 14, that's 16, this is x. This time we're looking for the altitude. The altitude theorem says part 1 of the hypotenuse over altitude and altitude over part 2. So I'm just going to set up that proportion. Part 1 of the hypotenuse, this is our hypotenuse, and it's split into 2 parts right here. Doesn't matter which one part 1 is, so I'm going to put 4 up there. Then that means part 2 has to be 16, so it's going to go down there. Our altitude this time goes in both these spots, and that's just x. We cross multiply, we get x squared equals, cross multiply this way, you get 64. Take the square root of this side, square root of that side. These cancel out, and you're left with x equals the square root of 64 is 8. So the length of that altitude right there in that picture is 8. The next one, number 13. This time they give us a picture, it looks like this, and what you had to realize on this picture was if they give you that picture, we did this a couple chapters ago, that's got to be a square. If I draw that in a square, then drawing that diagonal, then it has to be, these two triangles have to be 45, 45, 90 triangles. In a 45, 45, 90 triangle, the side across from the 45-degree angles, each time is going to be labeled L and L. And we were looking for X, that's that side up there. And the side across from the right angle is L times the square root of 2. Well, that's the one that we know this time, so we set up this equation. L times the square root of 2 equals 22. Now, this side up here is labeled X, but since this is a square and all these sides are equal, we could have just easily labeled this side X, so we'll find it. It doesn't matter which one of those we're finding. When we solve this, I'm going to solve it out radically. To get L by itself, if you're multiplying L times the square root of 2, all you do is divide by the square root of 2. Don't make this harder than it is. A lot of you making the radicals confusing. You just divide both sides by the square root of 2. That's going to get the L by itself. If you change this right now, if you grab your calculator and change that into a decimal form, I would probably accept that answer. I'm not going to. I am going to go ahead and work it out in radical form. But if you changed it to a decimal right now and found X from that, I'll know that answer. To solve this in radical form, I got to get that radical out of the denominator, so I multiply the top and the bottom by the square root of 2. On top then, that gives me 22 times the square root of 2. On bottom, it gives me the square root of 4. I'll rewrite this up here so I don't have run out of space down there. 22 radical 2 on top. The square root of 4 is just 2. Sort of ignore this radical 2 here right now and just look at the 22 and the 2, and those will reduce down. 2 will go into 2 once, 2 will go into 22 11 times. So out of all that, we end up with L equals 11 radical 2. Well, this side over here was L, or this side, whichever one we want to look at. So we know X has to equal 11 radical 2. The next one, problem 14. Problem 14 looks something like this. This time we're looking for this angle. Well, if we're looking for that angle, then we're probably using SOHCAHTOA, the trig ratios. So we got to label the triangle. That side's going to be the opposite leg. That side's the hypotenuse. This other side is the adjacent leg. The ones we want to deal with this time are those two. So the opposite and the hypotenuse. The trig ratio and SOHCAHTOA that deals with opposite and hypotenuse is the sine. So we do the sine of our angle, which this time we don't know, so sine of x equals the SO part, S-O-H, tells us opposite over hypotenuse, so 6 over 11. Remember, when you're doing this on the calculator, first thing you hit when you're looking for an angle is the second button. So on your calculator, you grab your calculator, you hit second sine 6 divided by 11, close the parenthesis, and you end up with about 33.06. 33.06. And I'd probably, you could round that off to where x is equal about 33.1 degrees, since we were looking for an angle. Next one after 14 is 15. So we're doing problem 15. And it looks something like this. This is 21, this is 75, and we're looking for x. If we know two sides of a right triangle, and we're looking for the third side, we could just use Pythagorean's theorem. So in Pythagorean's theorem, the only thing you got to remember is the side across from the right angle is always the hypotenuse. So that has to be on the side by itself. So that's 75 squared over there all alone. Then we got 21 squared plus x squared on this side, the two legs. Grab your calculator and you find 21 squared and 75 squared. And 21 squared is 441. 75 squared is 5,625. Then we're going to subtract 441 on both sides. These cancel out and you're left with x squared equals 5625 minus 441 is 5184. Then we take the square root of both sides. Square root of x squared is just x. Square root of 5184, grab your calculator, is exactly 72. So this side right here, this x equals 72. That's your answer. Next one. After 15 was problem number 7. Problem number 7. Problem number 7 looks something like this. We have a 30, 60, 90 triangle, so I'm going to label it like that. Side across from a 30-degree angle should be labeled L. Side across from the 60-degree angle, L times the square root of 3. Side across from the right angle, 2L. This is the one we know this time, so we just set those two equal to each other. So we end up with L equals 5. L equals 5. So everywhere we see L, nothing to solve there. Everywhere we see L, we can just stick in 5. We're looking for this side over here, so I'm going to come right up here and I'm going to stick a 5 in there in place of L. And that tells us 2 times 5. Well, 2 times 5 is 10, so that means X has to be 10. That's our answer. Next one after number 7 is number 4. Number 4. Number 4 looks like this. This side's 5, this side's 12, this side's X. You could use Pythagorean's theorem because you know two sides of a right triangle, you look for a third side, but I was hoping that you'd remember some of the Pythagorean triples or families and know that if one leg is 5, another leg is 12, then the hypotenuse has to be 13. So in this case, X has to equal 13. That's our answer. If you set up Pythagorean's theorem and solve it, you get the same thing. Do 5 squared plus 12 squared, your 2 legs equals the hypotenuse squared, which is X or C this time. The next one, number 21. 21. Problem 21. They give us a rectangle. And in this rectangle, they got a diagonal drawn in. And they tell us this angle is 60, this side's 12. And this is a right angle. Well, if that's 60 degrees, this has to be 30 degrees. And so we have a 30, 60, 90. We want to find the perimeter of this, so we want to find all the sides of this rectangle. Side across from the 30-degree angle should be labeled L. Side across from the 60-degree angle, L radical 3. Side across from the right angle is 2L. We really don't care about this 2L this time. We look right here, that tells us L equals 12. Well, if L equals 12, anywhere I see L, I can stick in 12. So I come up here, and that means this side should be 12 times the square root of 3. Well, if that side is 12 radical 3, then this side over here is 12 radical 3. And if this side over here is 12, this side is 12. Since they were looking for perimeter, instead of adding up and dealing with those radicals, might be better off just to change them into a decimal form. So you grab your calculator and you take 12 times the square root of 3. And I end up with about 20.8. So that tells me this side right here is about 20.8. This side up here is about 20.8. If I want to find the perimeter, I'm just going to add all those. 12 plus 12 plus 20.8 plus 20.8. 12 plus 12 is 24, plus another 20 is 44, plus another 20 is 64, plus the 0.8 is about 65.6. And I forgot to put any units on this one. So the perimeter of that rectangle is about 65.6. Problem 20. Problem 20, a 50-meter vertical tower. So I got my tower right here. A lot of people are having trouble with this. That tower is 50 meters. It's 50 meters tall. Is braced with a cable secured at the top. So we got some cable that's running from the top and tied 30 meters from the base. So that means it comes out here, or it's coming from the top, but it's coming out here this way 30 meters. And then right here at this point that's 30 meters away from the base, that's where your cable is tied down to the ground to hold the tower up. What angle does the cable make with the vertical tower? So we got the cable here, the tower here. They want to know what angle it makes with it. That's that angle right there. So we're going to be using our trig ratios. That's a right angle right there. That side is your opposite. That side's your hypotenuse. The side over here would be your adjacent. The ones we care about this time are the opposite and the adjacent. So if we care about the opposite and adjacent, if we go back to our SOHCAHTOA, that's the TOA part, the tangent. So tangent of our angle, which this time is x, equals TOA, the O over the A, so 30 over 50. Remember on this one, on your calculator, you hit second first. So all you do is you hit second, tangent, 30 divided by 50, close the parenthesis, and you end up with about, x equals about 30.96. We'll probably round that off, since it's an angle, to about 31 degrees. So that cable makes a 31-degree angle with the tower. The next one after problem 20 is problem 19. Problem 19. On problem 19, says a 24-foot ladder makes a 58-degree angle with the ground. So we got this ladder, it's 24 feet. It's touching the ground down here, makes a 58-degree angle with the ground. Apparently the ladder is leaning up against a wall or something right there. Hopefully the wall makes a 90-degree angle with the ground. How many feet up a wall will the ladder reach? So we're looking at this distance. You got to remember to put your variable in there. We'll have to use SOHCAHTOA again. So we label a triangle, that's opposite, that's hypotenuse. The side over here would be the adjacent. The ones that we want to deal with this time are those two, opposite and hypotenuse. Well, if we're dealing with opposite and hypotenuse, that's the SOH, the SO part. So that's the sine. So we do the sine of our angle, which is 58, equals opposite over hypotenuse, so x over 24. Grab your calculator and you find the sine of 58. Don't hit second this time, just hit sine 58, and you end up with 0.8480 equals x over 24. This is one of the nice ones. We put a 1 underneath this. When we cross multiply, we just get to x that way. So all we got to do is multiply 24 times that number. And I end up with about 20.4. And that's in feet. That's telling us that the ladder will go up the wall right here and reach about 20.4 feet, or about 20.5 feet. And the last one, number 16. Number 16 looks like this. A 67-degree angle here. This side's 20, this side's x. Since that's 67 degrees, we're probably using SOHCAHTOA again. That's your opposite leg. That's your hypotenuse. This would be your adjacent leg, the ones that we care about this time. Those two, opposite and hypotenuse. So that again is going to be the sine. So we do the sine of 67. This is just about like the last problem. Sine of 67 equals opposite over hypotenuse, so x over 20. Grab your calculator, find the sine of 67. Don't hit second, and you get 0.9205. Equals x over 20. Put a 1 underneath that. Cross multiply, another nice one, because that comes out to be x. So all you got to do is multiply 20 times that number. and you end up with 18.4. So the length of this side right here should be about 18.4. Again, make sure you show all your work, any problems, or whatever I told you I was going to give you on the Chapter 9 test. Make sure you turn this in.